Hello dear friends, welcome to another video of the Never Do Through the GUI what you can do through the CLI channel. I am Vangelis Prokopiou and today you are watching Rust proxy server with Warp and Hyper. I will talk a little bit about this project that I worked on and I have finished it. Not finished it, but it's production ready currently. So I want to talk a little bit about this. What was the experience of developing this application, why I did it. Plus, I will also share some useful stuff regarding how to set up a Warp TLS server or how to extract a hyper request from a Warp request. And another one very interesting is how to set up a hyper client which ignores SSL certificate warnings when you are in a development environment. So there are quite a few things to cover, so I will start. And I will start by saying that this application, let me have the code here. This is one of the things that it will be very interesting. Let me have the code here. And let me start by saying that this application, what is the usage of this application? This application helps me in my work to develop our client that we use and develop in my work. We have, of course, the services and a client, and the client is written in a JavaScript framework. So what we have to do in order to develop it locally is we have to have something like a proxy that proxies, let's say, all the local requests to the service, to the live service, not to the productive system, the production system, but the development system. In order to visualize this, let me open up Inkscape and try to help you visualize what this application does, because I think it is important. So in order for you to understand, let's say that this application is this rectangle, and this starts accepting requests, but in parallel we have, let's say that this is the service and this is the local client. So we have, this is another local server that it is running, and now the setup is that this one, the middle one, accepts requests from localhost, and it starts dispatching the requests based on where it should dispatch it. If it is a service request, let's say, it proxies the request to the service, but if it is, let's say, a client request, it proxies the request to the other local server that is running the JavaScript application. So this is what it does. It just accepts requests during our development and it proxies the requests to the correct destination. So I hope that the usage is quite clear. And in order to create this application, I used Rust, and the reason that I did that is because we already had a JavaScript implementation of this application with Node.js. So we had the Node.js server and running and listening to the requests, and then proxying these requests to the appropriate destination. But unfortunately, it was very unstable. We had many errors with Node.js. We had failures. The speed was not up to par, let's say, but let's leave speed aside because it was not a serious problem for the development. But the most serious problem was the instability of the application due to JavaScript errors with sockets, with whatever. So we had this situation, and I decided to provide this new implementation. And of course, I chose Rust. We all know why we like and we love Rust. For those that are not aware of Rust, Rust is a very robust language. It's usually used for systems programming because it gives you a lot of power. You can talk directly to the hardware, but at the same time it provides you with the safety guarantees, memory safety, and with a C-like speed. So as you can understand, it was a perfect candidate for me to write this application in Rust, and this is what I indeed did. So, as I said, we had this JavaScript application. I developed this Rust application. What was the experience during my development time? The experience is, I would say, demanding. I'm not myself a very experienced Rust developer, but as you can understand, Rust is very strictly typed, and you have to make all the types align. And there were some, let's say, some circumstances where I just could not find the correct combination of things in order to make it work. I finally, of course, resolved all my issues, and now the application is, as I said, production ready. We already use it. Unfortunately, I cannot run it locally here because both because I don't want to expose internal stuff with our systems, etc., but also because it's Windows oriented, and I have specific things, specific URLs that they are not available here, so I can't run the application. But this doesn't matter. We will go through the code, and I will also show you these specific things that I described. And in order to remind you, one is that I will show you how to set up a Warp TLS server. Second, how to extract a hyper request from a Warp request. And third, how to make a hyper HTTPS client that will ignore SSL certificates warnings when you use it with self-signed certificates, for example. So let me start with the first point, which is this one. How to set up an HTTPS server. This TLS means HTTPS server. So as you can see with Warp, it is quite easy. You only have to call this TLS function and provide the key and the certificate. These are, of course, self-signed certificates, and if you check here, they are configured here. I just read them from here, and I provide them to the server. So as you can see, this is very easy to set up this HTTPS server. But what I want to say regarding this specific topic is that, as the title of the video says, I used Warp and Hyper. The initial implementation was strictly with Hyper. I tried to create an HTTPS server with Hyper, and I indeed managed that according to some examples that exist in one of the, I think it's in Hyper TLS crate, if I'm not mistaken. So I managed indeed to run the server, but I had pressing errors about the fact that these certificates were not trusted. They were self-signed, and I could not bypass those errors. Whereas with this implementation through Warp, I just get the normal notification by the browser that this might be dangerous, and I can proceed without any further errors. So I am able to use this server. Whereas with the Hyper implementation, it was unusable. I could not get around the errors. I needed an actual certificate there, and of course it's not efficient, and I just want it for development purposes, so that route was not the right choice for me. So we have some, let's say, some abstraction here with the Warp server. To tell you the truth, I don't know how much overhead Warp adds on top of Hyper, but to tell you the truth, I don't care, because Rust is extremely fast, and as I said, speed was not a problem even with Node.js, and so much more with Rust. The application is running like a breeze, and it's very, very stable. It's rock solid, I would say. So this is the first point that I would like to address: how to set up a Warp TLS server. I also want to say that these code samples, I will add them to the respective GitHub issues, because there are related issues in the Warp repository. Plus I will make some posts in order for other people to be able to solve these problems. So this was the first point. Let's continue to the second point, which is extracting a Hyper request from a Warp request. So why did I want to do that? The part of the code is right here. Why did I want to extract a Warp request from a Hyper request from Warp? Because, as I said, I just wanted to use Hyper, the Hyper client, and not include any other library like requests. I just wanted to take the Warp request and feed it as it is to the Hyper client, and then the client should dispatch the requests and give me an answer. So in order to do that, I had to extract the Hyper request from Warp, and the way to do it is, as you can see here, this is the way I do it, and of course this is also some of the information is provided in the GitHub issues, but it was not complete, and the information that exists there is not totally correct. But this implementation that I am showing you currently is working with the latest Warp server, Warp library. And to get into it a little is, we start with any request, and we get the method of the request, we get the path. Here we get the query string, if there is a query string, and if not, we just provide a default string, an empty string, because by default this implementation returns an error if there is not a query string. So we have the method, we have the path, we have the query string. Then we get the headers of the request. Then we get the body of the request. And all the above elements, all these are available in this map method. So as you can see here, I have all my pieces in order to create the hyper request. I have the method, I have the path, I have the query params, I have the headers, and I have the body. In here I check if I have indeed any query params and it is not an empty string in order to create a full path. And this full path will be fed here to the hyper request builder. As you can see, I initialize here the request builder. I provide the method, I provide the URI, I provide the body, and then we also provide the headers. And then in this map method we create the hyper request, we return it, and we had it available here in our handler. This is the Warp handler. And now this is a part where I had really big trouble making this work, because I had to make the types align. I had to use something that implements a future, plus I had to handle the different errors that I get. So if you see here, this handler has this signature. This is the signature of the handler. It accepts a request with a body and returns a result with a response and the body. This is these are the types. This implements future. Plus I had to handle a possible error, and the handling was made through this map method. But here of course I have this error. The correct thing to do is to match on this error and do what you have to do according to the error that is returned. But for now I have this not found rejection by Warp. It is something that I will have to look into, but at least this piece of code was the last part that I was missing, and it made this whole part work. So this is the second point of extracting a hyper request from a Warp request. This is the whole code, as you can see. Of course, you can extract this part, all this part, in a separate method in order to use it with an end filter. You can say end and then your method that will execute all this code. But in my specific case, I didn't matter having it here in line. So we have the request, we pipe it to the handler. And let us take a quick look at the handler. And then I do various stuff according to the URI. If the URI is slash, I redirect where I want to redirect. And then all I do is map the URI that I get from the request to the correct relay point. The relay points are provided through these JSON files, these configuration files. Where are we? Here. I find the correct relay point, I build the proxy URL. I have to clean up some things with regexes. This is another interesting point here. As you can see, I have regexes in here, but using lazy static has the effect of building the regexes only once and not in each time the handler runs. We replace the stuff, plus I have some cookie handling. Here I just fix the host and the origin headers in order to provide the correct ones and not localhost. Here I handle headers and cookies. I did that because the initial implementation was not HTTPS and some cookies were not saved to the browser, but now the cookies are saved to the browser, so I have to check if all of this code is indeed necessary. And after I do that manipulation, I perform the request here. I provide the request to the hyper client, and then all I do is, of course, this is again related to cookies and headers. I get cookies from the response, and our handler returns the result. Now, if you are curious about this HTTPS client, this is again a static reference. It's within this lazy static block. It's global. I create it once and I use it for all my requests. And this brings us to the third point, which is how to set up a hyper client which will ignore SSL certificate warnings. And this is the way to do it. Let's say one of the ways to do it, because I'm using hyper TLS. Yeah, let me check myself, please. No, native TLS. So let's go first of all through the way to build this client. I use a native TLS connector builder. I provide these two flags, danger, accept invalid host names, and danger, accept invalid certificates, and I build it. Then I build a new HTTP connector, hyper client HTTP connector. I provide this flag to the connector, and then I build here the HTTPS connector. Here it is. This is a hyper TLS HTTPS connector, and we build it with this HTTP connector and the TLS configuration here, the TLS connector. This provides us with the HTTPS connector, and finally we use this HTTPS connector with our hyper client. As you can see here, let me put it on this line. This is how we build our client. I have the fully qualified names, as you can see, and I did that on purpose because I want to be able to understand what type everything is, because if I have imports at the top, sometimes I do not really understand what type is its variable, etc., and this helps me. Of course, this is a matter of preference. So this, as I said, this is one way to do it, but I want to change this and use Rust TLS instead of native TLS. I have to look into it because Rust TLS is already required by Warp and by Tokyo, so I can use that and not include another library, like another crate like native TLS. Plus, the Rust TLS implementation is a lot safer than the native TLS, which uses OpenSSL. This is the overview of the application and the information that I wanted to share. I know that it is a lot of information, but I hope that it will be useful at least for people that are interested in Rust and in these specific crates like Hyper and Warp. And I believe many people are interested in this framework, in the Hyper framework, because it is used by Amazon and it is built and maintained by people that work in Amazon. So you can understand that they are very serious with that implementation, because Amazon also uses this library. So I hope, again I repeat, this is all the information that I wanted to share. I hope that for the Rust fans will be useful, and I will be seeing you in a future video. Thank you for listening and have a great day.